Welcome everyone. My name is Yamil Guevara. This is the fifth video on a video series on machine learning algorithm. In this video series, we are covering all of the machine learning algorithms. In this video, we are going to be covering an unsupervised machine learning algorithm called K-means clustering. There are many models for clustering out there, but in this video, we are going to be covering a model that is considered one of the simplest models among them. Despite its simplicity, the K-means is vastly used for clustering in many data science applications. It is especially useful if you need to quickly discover insight from unlabeled data. In this video, I'm going to show you how to use K-means for customer segmentation. There are other real-world applications for K-means. For instance, you can use it for customer segmentation. You can use it to understand what the visitors of a website are trying to accomplish. You can use it for pattern recognition. You can use it for machine learning. And of course, you can use it for data compression. So these are few of the real world application for K-means. Now, let's go back to this specific video. So in this specific video, we are gonna covering K-means to do customer segmentation. And I want you to think about the following. Imagine that you have a customer data set and you need to apply customer segmentation on this historical data. Customer segmentation is the practice of partitioning a customer base into groups or individuals that has similar characteristics. It is a significant strategy as a business can target these specific groups of customers and effectively allocate marketing resources. For example, one group might contain customers who are high profit and low risk, that is, more likely to purchase products or subscribe for a service. A business task is to retain those customers. Another group might include customers for nonprofit organization and so on. So customer segmentation is very useful for marketing purpose. And that's what we are going to be covering here. So let's begin our journey. And you already know what's the first step in creating a machine learning algorithm. If you've been watching the previous videos, you know that the first step in creating a machine learning algorithm is to import our libraries. So we're going to be importing the following. We're going to import in random. We are going to be importing NumPy as NP. We are going to be importing matplotlib as PLT from sklearn cluster. Import K-means from sklearn. Dataset. Samples generator. Import week. And of course, since we're using Jupyter Lab, we have to type matplotlib inline. So let's run this code. Okay, no problem. So everything runs perfectly. So let me scroll this up. Now, the second step, I think you already know. The second step is to always import a dataset into the Python environment. So that's what we are going to be doing. I forgot to actually import one library, and that's pandas. So I'm going to be importing pandas as PD. Okay, let me run this code. Excellent. So let's import a data set into a variable called customer DF. And DF stands for data frame. We are going to be using pandas to read our data set, which is a CSV file. And our data set is customer segmentation CSV. And of course, I always want to look at my data set. And the way you look at your data set is by typing this code. So let's run the code. Excellent. So here's a data set, and here are the first 4 rows of data set, 5 rows of data set. So we have all these variables: customer ID, age, education, years employed, income, card debit, debt, other debt, default, address, and debt to income. So this is an unsupervised machine learning algorithm. And since it is unsupervised, we don't tell the machine learning algorithm our independent variable and our dependent variable because that's not what we're looking for. We're just trying to group the data into similar groups. And this machine learning algorithm will do that for us. It will group data into similar groups. Okay, that's the whole point of it. Okay, let me scroll this up. Okay, so now, as you can see, address in this data set is a categorical variable. K-means algorithm isn't directly applicable to categorical variables because the Euclidean distance function isn't really meaningful for discrete variable. So we need to drop this feature and run clustering. So let's do that. As always, I like to look at my data. So let's run. So this code is going to drop address for my data frame. Let's run it. Okay. Oh, okay, I made a mistake here. That's supposed to be that. Let's run it again. Okay, here it is. So as you can see, we just dropped the address column. As you can see here, the address column was before the debt to income ratio, and it has been dropped. Why it was dropped? Because it was a categorical variable, and the k-means algorithm isn't directly applicable to categorical variables. So we did that. Let's move on. Let's continue. So now the next step is to normalize our data set. So we need to normalize the data set. But why do we need to normalize the data set in the first place? Well, normalization is a statistical method that helps mathematical based algorithm to interpret features with different magnitudes and distributions equally. So we use the standard scalar function to normalize our data set. So let's do that right now. We are going to be using a pre-processing. Standard scalar values. And mistake here. Df values. Pi. Indicator. Gonna fit it. Transform. Okay, so let's run the code. Okay, so we have a problem here. X is not defined. Let's see. Oh yeah. You know why? Because that's a lowercase x. This would be a higher case x. Let's run the code. Okay, so there is an error here. So let's see what's going on here. Okay, give me a second. Find out what's going on here. Let me look at this code real quick. Hold on. You see if there's any error here. Okay, I think I see the error here. I think I see it right there. Let me run the code one more time. Okay, perfect. Error has been fixed. So we had normalized our data set. And again, the reason we normalize this data set is because the statistical methods that we're using, the algorithm, they only interpret features with different magnitudes and distribution equally. So we need to make sure that everything is equalized or normalized, okay, or all our values. So we've done that. It's time to create our model. Okay, let's scroll down. Let's scroll down. Okay. Okay, so let's apply the k-means algorithm to our dataset and then look at the cluster labels. So let's do that. All right. Okay, so cluster k-means clusters, cluster none and unit 12. I'm gonna fit that model labels. Print labels. Okay, so let's run the code. Okay, perfect. Yeah, everything looks perfect, right? We have our labels. Okay, so let's go down, let's go down, let's go down. Now we need to assign the labels to each row in a data frame. So let's do that. Labels. Yeah, let's run the code. Excellent. Now we can actually check the center values by averaging the features in each cluster. So let's do that. Let me scroll up. Let's scroll up. Okay, let's do that. Yeah. Group by cluster. Okay. Mm, let's run the code. Excellent. Now, what we need to do next. So let's look at the distribution of customers based on their age and income, okay? So let's do that right now. Give me a few seconds. Let me scroll up. Okay, let's do this. Let's do it. Area. We're gonna use numpy. Pi. Okay. Okay. Input. 0.9. Beauty. X label. Age. Font size. Font size 18. 18. White label. Income. Size. DOT dot show. Okay, let's run the code. Okay, so we have a problem here. Positional argument follows keyword argument. Okay, let me look at this code. Okay, so let me look at this code to see where I made the mistake. Oh, here. That's where the mistake is. That's equal to equal. Okay, any other mistake? Okay, let's run the code. Okay, perfect. It worked perfectly. So here's what the machine learning machine learning algorithm just created. The K-means machine learning algorithm. It grouped the data, and it did this by itself. It grouped the data based on income and age. So it has these three groups: the first group, the second group, and the third group. And as you can see, younger groups of people actually have lower income. That's what it means. But now let's have a 3D model of this um, of this grouping of this clustering. Let's have a 3D model so we can actually see it better. So I'm going to create a 3D model of this clustering of data points. So let's do that. Give me a few seconds. Up. Okay. So let's create a 3D model of the clustering that the K-means machine learning algorithm created by itself. Remember, the K-means machine learning algorithm is an unsupervised machine learning algorithm. So I didn't tell it to do anything for me. It actually did it automatically. So that's what it did. 3D, okay? 3D. Here. Okay, dot. Size equals 8, 6. See the left, nice. Display, set, X label. And be education. We are naming our labels. Let's continue naming our label, set Y label. Let's continue setting a label, set Z. Okay, so here's a 3D model. We're going to be using a 3D model to look at the clustering that the machine learning algorithm created. Remember, K-means is an unsupervised machine learning algorithm. So it created three clustering automatically by itself. And I didn't tell him to do anything. I didn't tell him group this customer by these demographics. No, it did it automatically. So let's look at the clusters that it created automatically. Okay, so there is an error here. Axis 3D is not defined. Okay, let's see. Axis 3D not defined. Let's see where is it. Oh, that should be capitalized. Okay, let's run the code. Okay, perfect. It did it. Okay, here's a 3D model of the clusters that the machine learning algorithm created. Again, I didn't tell it to do anything. This is an unsupervised machine learning algorithm. So it created all these clusters, and we are now representing them in a 3D fashion. So what does this mean? This means that K-means, which is the machine learning algorithm that we just used, just has partitioned the customers into mutually exclusive groups, okay, into three groups, okay, income, age, and education. The customers in each cluster are similar to each other demographically. Now we see the profile is as follows. It has created three clusters. So it has based on the demographics of the customer, and it did it automatically. It has based on the cluster are based on affluency, the education, and the age of the customer. The other cluster is based on the middle age of the customers and middle income. And the other cluster is actually young and low income customers. So it actually created three clusters, and each cluster actually is demographically similar to each other. And again, I want to emphasize that this is an unsupervised machine learning algorithm, and it did this this clustering of customer by itself. I didn't tell them to do anything. I didn't tell them to cluster the customer based on income, age, and education. It did it automatically. Okay, so this is the end of this lesson. Please, I want you to, if you like this video, please click like, subscribe to my channel, and make comments down below. I wish you all the very best. Have a great day.